Volcanoes can be scary, but scientists around the world are working hard to understand them. They collect clues from the Earth to help predict when these events might happen and how to stay safe. Scientists study volcanoes in different ways. Some go out into the field to observe volcanoes directly. They record videos, measure gases coming out of vents, and even collect lava or ash samples. Others place sensors around the volcano to monitor ground movement or other changes. Some scientists study satellite images to track volcanic activity from far above. By putting all these pieces together, field data, satellite views, and monitoring tools, scientists can better understand the complex things happening inside a volcano. This is really important because we can't always see what's going on underground just by looking from the outside. But in this video, we're going to show how experimental methods can help us study volcanoes. Before we jump in, let's go over two important concepts in volcanology: magma and cracks in rocks.
Deep inside the Earth, temperatures are so high that some rocks begin to melt. This melted rock is called magma. Magma forms when the heat and pressure inside the Earth becomes strong enough to turn solid rock into a thick, glowing liquid. It gathers in large underground pockets called magma chambers. Magma isn't just melted rock. It also contains gases such as water vapor, carbon dioxide, and sulfur dioxide. These gases are trapped inside the magma, like bubbles in a soda bottle before it's opened. The amount and type of gas are important factors that affect how magma moves and can even determine how it reaches the surface. That's why volcanologists carefully measure these gases to better understand a volcano's behavior.
Even though rocks seem solid, they can crack, especially deep underground where there's lots and lots of pressure. These underground cracks are important because magma can move through them to reach the surface, and sometimes that's how an eruption begins. Now that you've learned about magma and cracks, let's get back to how experiments can help us study volcanoes. A lot of things happen inside volcanoes, but we can't just look underground to see them. That's where analog experiments come in. These are lab models that copy how real volcanoes behave using safe materials like water, sand, or gelatin. Even though they're simplified, they help us test how real volcanoes behave, like how magma flows, how gas escapes, and how eruptions might begin. It's like building a mini volcano that we can actually watch and measure, but without the actual danger. Now let's take a look at a real experiment in a lab here at Michigan Tech. We study cavitation. That's where bubbles form and collapse in fluids like water. So why does that matter? Cavitation happens when magma pushes through cracks in rocks. These bubbles help magma move more easily, and sometimes they can add extra energy to the system. That extra energy can help even trigger an eruption. That's why scientists are interested in studying this simple but powerful process. To learn more about this, I spoke with James Davis, a Ph.D. student here at Michigan Tech. He studies cavitation. So James, tell me what you study in your Ph.D. research.
So I study how bubbles in cracks filled with liquid form. I even built a lab experiment that helps us understand why these bubbles appear and pop. This helps us learn how similar bubbles in magma inside volcanoes might form.
That's really cool. Can you show us your setup?
Of course. So this is my experimental lab. It has three main components. First, there's the light source, a powerful laser that lets us see what's happening inside the crack. Secondly, we use optics or special lenses to spread the laser light evenly across the whole crack. That way, we can see everything clearly. And third, we have a high-speed camera that records what's going on really fast, thousands of frames every second. Then we have our crack sample, which we place in the middle between our laser and our camera.
So how do you actually model a crack in the lab?
We actually use 3 pieces of plastic stacked together like a sandwich. The middle layer is special. It has a thin cut in it, which acts like a crack. Then, we hold everything tightly in place with bolts and metal plates, just like rocks would press together underground. So this tube is connected to the crack. So by injecting this tube with water, we can fill up the crack. Then I place this piston and strike it with a hammer to create cavitation. When you strike it with a hammer, it simulates a natural scenario in which magma presses against rock.
Could you tell us one thing you found that affects cavitation?
Yes, one really important factor that we found is the amount of dissolved gas Every liquid has a tiny amount of dissolved gas in it. For example, water has dissolved oxygen in it, which is how fish breathe underwater.
So how does that matter for cavitation?
That's a great question. I'm going to test two cases. In the first one, the water has a normal amount of oxygen. And in the second one, I've removed all of the oxygen from the water. So then I'll show you what happens and how gas changes the way bubbles form. After assembling the crack model, I place it on the stand and fasten it to hold it in place during the experiment. Once it's in place, I turn on the high-speed camera and adjust the optics. Then for safety, I put on my laser safety goggles and then turn on the laser. Here, you can't really see the laser due to the background light. So in order to see the laser more clearly, I turned off all the lights and took this photo. Once everything is on, I fill the crack sample with water. Then I initiate the experiment with a hammer. The striking of the hammer causes bubbles to form in the crack. Are you ready to see the results?
Absolutely.
Here's the first test. With normal water. Look at all those bubbles. That's cavitation happening again and again. Now let's look at the second test. As you can see, with low oxygen, there's no bubble, which also means no cavitation. This shows us that dissolved gas helps cavitation happen. Without it, it's much harder for bubbles to form.
That's amazing. Just the gas in the water makes such a big difference. So James, tell me how your findings are related to volcanoes.
It's a great question. So, as I mentioned previously, like water has air bubbles that fish can breathe, magma has its own gases. The amount of gases determines how much cavitation happens. So, in volcanoes, these bubbles, they can add more energy into the system, and that can cause an eruption.
We've seen how scientists at Michigan Tech are using creative experiments to understand one of nature's most powerful forces, volcanoes. Even tiny bubbles inside a crack can tell us big things about how an eruption will begin. By studying safe models in the lab, scientists like James are helping us unlock the secrets of what's happening deep under the earth. And who knows, maybe one day you'll be the one making amazing discoveries about our amazing planet.